I didn't even say anything and y'all got quiet. I like that energy. Well, welcome. Now, hold on, before I get started. Half of the folks aren't in this room yet, which we're going to have to figure out how to fix that. I don't know if they went too hard last night. Boss is making them work, but those chairs should be full in the back. Anyways, listen. Welcome to that conference. I am ecstatic to be here again. This is our second time in Texas. How many were in the first Texas? No, we can't do that, Martinez. When I look back, the last 8 months, we've managed to do 3 shows, which is not the way it was supposed to work. And for a team of 5, quite an accomplishment. So I just want to start by thanking my crew, Hillary and Brandon and Brett, my wife who's not here, Darrell. Let's give them a round of applause, although they seem to be hiding. I see 1, 2. I couldn't do it without them by any stretch. So thank you, V2. We've got a lot to talk about, and we're going to lean in and get a little vulnerable. We're going to go from there. So let's start with where we are in the world today. My name is Clark Sell, husband, father of 2, and apparently AI thinks if you ask it with my image and say, that conference, full-body cowboy riding a bull, Texas wartime propaganda poster Tron style with electronics and neon, this is me. And I gotta be honest, it's sexier. So I got the shirt to match, just so I'm in like kind of the full thing, and I'll have to go find a horse and a hat. So maybe by the end of the week, I'll be full AI. I think a lot about why we're here, and I think we're in a time where things are unique and special. And I say that because I've been running events now for roughly 15 years, 16 years, and I've seen the ebb and flow of people and speakers and sponsors and topics. I love to tell the story about mobile and how it started native, and then it was hybrid, and then it was this other thing, and then it came back to going over here, and it's like this constant like fight of like, no, this year it's this. No, this year it's that. But throughout everything, there's a group of people who step out, get involved, and give. I'm not standing here to run a conference. That's the last thing I want to do. I didn't set out to be an event planner. Last thing I want to do. What I set out was to help the community grow. And we're in this time right now where if you look around, all of you are the people who stepped out. And there won't be this in a couple years. And what this is an opportunity where the anarchy is not so high that you can lean in and really get to know somebody. When there's 1,500 people, that opportunity to really sit down and engage with somebody and learn about them isn't there. And this is about what we can do in person together. Because when you leave, you're still a community, and you're still people, and you still need one another. 4 years ago, I asked a simple question, and I couldn't sleep at all last night as I have this habit of like waiting till the last minute to put things together. So I got up at like 5 and was sitting out in this gorgeous weather, trying to think about why are we here? Like, what's the thing we're going to do? And I remembered this video from 4 years ago that we made, and I think it's a good way to start where we are today in this world of whatever it is in 2023. So let's watch a few minutes of this, and I want you to think about how you would answer this question yourself.
How would you define community? How would you define community?
Man, that's a great question. And I wish you'd have told me 2 days ago you're going to ask me that.
How would you define community, and what does it mean to you?
Well, this is a good question. I haven't thought about it.
Yeah, that's a really interesting question. How do I? God, that's really fun.
Wow.
Yeah. Oh, that's a good one.
Ooh. Okay. So community to me is.
You know, it's almost like if you're in church, and how do you define church? Is it a place you go? Is it something that you experience? And
I think of community as my closest friends.
The first word that popped into my head was opportunity.
I think the first thing I think about is empathy.
Probably support.
People who are willing to share and help each other.
Community is finding your people.
My definition of community is everybody.
Relationships are more important than any given person, any given entity, any given organization. And that's what I love about any community, specifically the communities that I'm in, the developer communities. When we get together and share things, some magic happens.
Community is one of those things that actually made software more accessible.
I think it's the people that I interact with on a daily basis. It's not just when you go to the coffee shop and you see the barista that makes your coffee, but it's the people that you have an ongoing, consistent relationship with, that you say hi to in the morning, that you actually say, hey, how are you doing? That you're willing to sit down, have a cup of coffee with, have a beer with.
I know it's super important to me because, like I mentioned, I feel grateful for where I'm at in my career. My problem now is I can't say no problem. I want to go to this meetup group over here to show them that, you know, I'm a woman and I can do this too. Or if there's women that go there, to be like, you have support. We're all here together, just to be an example, someone to reach out to. I think it all boils down to me is just support.
The medium doesn't matter. We can have communities online, we can have communities offline. It's whatever you use to share knowledge. And it's whatever you use to kind of learn from each other, give back, and build a family that believes in the same things that you do. Maybe not necessarily the same views. It's perfect to have differences.
I think community is a group of people that provide support and criticism, appropriate criticism, because they're invested in seeing something grow and become better than it is. And sometimes that means being humbled and taking a step back, and sometimes that means stretching yourself beyond what you think you can do to get to that next level.
For me personally, I like to go out and help and grow people. So I like to go out there. My kids, have grown up here in Northeast Wisconsin, and, the better that I think there's opportunities and jobs and the ability to connect, becomes an important part for why a community is vibrant and evolves. And I think part of doing that is, making sure that people feel confident in what they're doing, or imparting skill and helping them grow into the person that they want to be.
I was an oddball, right? Growing up, I was a girl who liked Star Wars and liked video games and got made fun of it. And then when I finally found people who loved the things that I did, there's no better feeling in the world. Like, it's Maslow's hierarchy. It's that feeling of acceptance. And so community is finding your people.
When I go to my meetings and things, I'm hanging out with a group of people that think like I do, that face the same challenges that I do, that I can truly relate to. And so when I go to conferences and I hang out with other speakers or attendees or whatever, there's a real connection there.
To me, community is having other people walking their paths with you,
maybe not the same paths, but somebody else who's on the same kind of journey, and you can support each other in the journey.
My biggest takeaway is, you know what? It's great to consume knowledge and read what you can and watch videos and build your home lab and this stuff. But I think if we're really going to be successful, we need to do it together. And we need to, quite honestly, do shows like this, Clark, and share and give back. It's a bi-directional. It's not a unidirectional thing when I think about community. So the more you can give back, the better off we'll all be.
I think it's so wonderful every time that I go to one of those meetups and I meet somebody new who doesn't have, like, who may not be in the community yet, but like they are interested in Raspberry Pis, and they find this meetup and they go to the meetup around Raspberry Pi, and then they find other people, and then I think about how many jobs and how many friends I've known who have gotten jobs or connections to jobs through the people that they've met through the community.
They are folks that, even if I haven't seen them in a long time, when you see them again, you know, you feel that instant connection, that you know, as if not a whole lot of time has actually passed.
It's opened up these possibilities through, I like to build things and I like to put them on the internet and show people. And through that, I've had these doors open to be connected to people, you know, people like you, people like Robin, people like, you know, I've met like people who build the internet, you know, like the Apollo team, React team. And I'm sitting down talking to these people who are having an enormous influence on the way the internet is going. And really the only reason I'm doing that is because I got on the internet and started sharing. And I think that's what it is for me. It's a door. And it's just kind of boundless possibility as long as you're willing to put yourself out there and say hi.
You know, the last 3 years have disrupted this world in ways that we are yet to even find out. And I feel it a lot as we're trying to get this event going, and I meet user groups that aren't around anymore, and other conferences that are dying, and these companies that have changed how they get together. And I thought of this video, and I'm thinking, this is how we all connected and propelled ourselves forward. Look, I love online stuff, but it also doesn't replace in-person stuff. And I just encourage all of you to remind people that there are other places to get involved, other communities to get involved. There's not just one. They're all over the place. And the reality is, we need each other from a human, psychological perspective. And as we get through all of this, we need to make sure that we don't lose our DNA of how to be the best community, how to be the best people that can support one another. In 2020, I had asked everybody at that conference to submit a set of words that defined what they thought the community was, and that's where this logo came up. Seems like yesterday when we did it, and then you look back and you're like, holy shit, that was 3 years ago. So think about your time here. Think about the connections you're going to make. I wanted you to sit at a different table because it's a new connection, right? Get outside your comfort zone. When I think about here and our time together, it starts in one of these campsites. It starts with the fact that I gave you the question to ask somebody else. You're either there because you're interested in a topic, the speaker, some exposure. You have something in common with the person that's sitting next to you. These are set up purposely like this so that you're forced to kind of lean in a little bit. Not just hide in the back, but lean in and meet the people that are there. It's a campsite. Make it your own. But it starts there, and it doesn't end there. It comes back out here. It's in the hallway. It's with the sponsors. It's during open spaces. it's the whole time when you're here. So it make those connections. We've had this this metaphor, I guess, going on. It started 2019. Somebody brought a puzzle and said, can you finish your puzzle before the weekend or before the 3 days are over? And they did, of course. So then the next year, or whenever the next time was, we got a harder puzzle. And then they did it really quick. We did it really quick. And then in Texas, 8 months ago, we got a white puzzle or something, and I thought, there's no way in hell this is going to get done. Sure enough, 14 hours later or something, it was done with like 10 pieces missing. So we returned it to Amazon because it couldn't be completed, which is just a sick mind trick on anybody who's shipping puzzles. But there's a puzzle in the back. Oh, actually, hold on. In Wisconsin, I got another one. It was just, what was it, lines or I forget. And y'all smart geeks figured out that there was numbers on the back of the thing. So flipped it all over, sorted the numbers out, and the next thing I know, it's done in like 30 minutes. And I'm like, yeah, I should have known. There's a way around something. We're going to find it. So there's a couple puzzles in the back, and I challenge us. Put a piece in, right? Connect it. Think about it. Let's see if we can finish it. Before I bring whurley on stage, again, thank you for coming, for buying a ticket. The costs are through the roof. I know a lot of people that came in, 2019, and you come now, and it's like you got slapped by a freight train. It's gotten on hand. But we can't do any of this at all without the support of our sponsors. My company, Unspecified, Intellibus, Vonage, Front Egg, Yum, and a host of others, they're all here because they believe in the same thing that you do, right? They have a choice of where they go. And I want you to go out, thank them, learn about them, and see if you can connect them, right? We're all connectors. This is the smallest community ever, and yet we pretend like it's so big. For example, whurley, I met in like 2008. I'm like, this dude's pretty cool. Got this cool company name, flinging around on skateboards. Like, I am not worthy. And then you find out, well, he knows him, and he knows him, and he's over there, and then this person's attached to him. And then you realize that this network map, that we're all like 6 degrees of Kevin Bacon, right? Somehow, we're all very quickly connected. And it blows my mind. We get imposter syndrome and we're afraid to talk to people. One of the best tech books I ever read, The Pragmatic Programmer, and the author sitting over there. Like, it's just mind-bending, the opportunity we have when we... Oh, now I'm confused. Oh, you got to go. Is that it? Oh. Oh, I can do that. Oh, you're trying to get me to stall? I got it. It's just mind-bending to me how close we really are, and yet sometimes it feels so far apart. And sometimes the internet kind of makes that happen. So since I have to stall, we're going to skip to the end of this presentation. Open Spaces kicks off today at like 12:15, I think, or 12:30. This, for me, is like one of the most magical things I think that we have. This is an opportunity to have an unstructured conversation. I could pick as many speakers. You can vote on as many speakers as you want. I'm never going to get everything that you really need. That's where Open Spaces comes in. How can you have a conversation that's contextually sensitive right now? How do you ask for help or give help, right? Hey, I want to learn how to make a paper airplane. I'm going to do it at Monday at 1 o'clock, circle 16. Just show up, right? It's that spirit of what's happened in open spaces, which we're trying to put online on that.us. And when I learn how to market things, you all will get it. So that's at 12:15. We're going to have a happy hour outside in the market. I think it's called Armatuli. And I want to thank Isaac for sponsoring that in AWS. Game nights after in here. So if you got some games, we've got some. Come, hang out, have fun, play. And then tomorrow, we've got a barbecue over in the barn. If you're one of our members, we're gonna have a little thing beforehand. And due to just budgetary reasons, I unfortunately have to cancel the water park. But the weather's so nice. We're gonna go back to the days of early Twitter when the old fail whale was a thing. Now it's just errors. And we're going to do the old takeover. So that bar with the big tree and the fire pits outside, we're just going to show up at 7:30 and have a good time. And they're not going to charge me for it. Yeah, that's called a takeover. Like, there's two ways around this stuff. Hope they're not listening. Also, this is something that we originally started with the kids, but I think the adults like it more. And that is outside in the middle, there's this thing called a marble wall. So, of course, we have 3D printers. Well, my wife won't let me get one. But, 3D print a thing, the challenge is how can you get the ball around the wall? So have some fun. Like the puzzle, let's see the geekiest contraption that we can kind of put together and get it to go around. Next up, if you're not in our Slack, is anybody not in our Slack? Oh, come on. Chastising later. It's in your profile. If you go in your profile, under profiles, you can hit the button that says join Slack and it'll pull you in there. Also, your shared profile, that's the thing that gets exchanged if you give your PIN number to one of the sponsors. I've got a bunch of stuff from past conferences that we're going to try to offload and sell, so if you want to help support us and wear some swag, we've got some stuff. I'll put this up later if you want to stay in touch through Telegram. We're trying to get better ways to just make sure everybody's informed. I'll come back to that later. All right. Do I have to stall anymore? Do I need to do a dance? All right. Oh, I can. I don't know. Hey. This conversation started when I say that the world is small. I worked for a gentleman named Mike that I adored. I learned a lot from him. And then through reconnecting with people, ended up back with whurley that hadn't talked to in I don't know, probably a decade. And asked, hey, would you like to come talk about what you're doing to this audience? Austin native, can I say Austin native? Is that a proper? Lives in Austin or outside of Austin. Super busy individual, but when it comes to developers, when it comes to the community, I can't think of a person who's more involved. And it's a great pleasure to have you come and speak for us. So let's give whurley a big round of applause.
All right. The level of professionalism you're about to witness as the slides just work perfectly on the first try.
Were you doubting my cables?
No. Oh, still any second now.
Well, you're good. It's done.
Really? But they can't see it.
Well,
I can see it.
I mean, my crew's a little behind.
There we go. Like, I can see the presentation. It might be useful if you could see it. All right, I have to ask this because of the amount of nerds and or geeks in the room. How many of you, did anybody go to the Long Center last night? That is shocking. So, unbeknownst to me and out of nowhere, a friend called and said, William Shatner is talking at the Long Center tonight, and I've got tickets. And you're the only person I know who knows anything about sci-fi. Would you like to go with us? And so I dragged my poor wife along to see Star Trek II, The Wrath of Khan, in a giant echoey like this right now theater. And then I found out, one, that William Shatner is still alive, and two, he is out of his absolute effing mind. It was just insane. I was hoping that, more of you would have seen it because there'd be a little context. But let me just tell you, at one point, he talked about a kid throwing candy at Jeff Bezos's dark star while they were weightless. And I was like, it is completely off the rails. But it gave me confidence for today because I knew there is no way I will come off sounding that crazy, which I often do, because today we're going to talk about quantum computing. And so I want to start with 3 key points, first of all, that I think are going to be really, really, really important. The first one is purposely kind of inflammatory, but I'll explain. There's a point to it, which is that quantum computing, not AI, is a space race of our generation. Now, that doesn't mean that I want to belittle AI or that it's not important. It does mean that I think mostly what we have in AI today is really, really great automation. I think we keep moving the goalpost, right? What we used to call an artificial intelligence is a superintelligence, and on and on. And by the way, that happens, and winters happen, and there's no criticism to AI at all. I actually see a future in where AI and quantum converge, and I don't believe if you think nature is quantum mechanical, and you believe, therefore, the brain is quantum mechanical, that you can have a true AI without first having the prerequisite of a quantum computer that's general purpose. And so I believe that, if you look at the amount of investment, at the pacing, and we're going to cover all of this today, and then what the technology does at its fundamental core, you'll probably, hopefully, at the end of the presentation, agree with that statement. So it's also not about big data. Quantum computers don't have any memory. There's no way of storing data on them. There's no way of doing anything to manipulate data. And a quantum computer works differently, similar to a lot of AIs you may be familiar with. It's a black box. So we can see how a computer works, but we can't see how a quantum computer works. It just kind of happens, and we get a result, which means it's not about pumping a lot of data or big data. It's about big math. It's about calculations that we'll talk about in detail that we just simply can't do today that are vital to the future of our species. And then the last thing is that it's commercially viable now. We have a small software startup in Austin doing quantum computing software. We're going to show you that at the end of the presentation. And, we're making money. Is it billions? No. But for an industry this early, to be able to even remotely draw in the type of revenues it is, it's a very, very big deal. And so is it where we want a general purpose computer? No, it's not. Is it something that you could get into, you could start writing software for, developing software for, participating in? Absolutely it is. So with that, let's go all the way back into the past of quantum computing. So here's what we're going to cover. I'm going to give you kind of a brief history lesson. Then we're going to tell you where the industry is, and we're going to talk about the funding and the technical progress. We'll talk about the machines and how they work and all of that. And then we'll dissect some quantum algorithms, because that's always super fun. My wife's always like, I hope you're not going to go travel to some stage in another state and be doing that quantum algorithm saying that thing's a lady killer. I'm like, yep, sure is. It bore them right into a coma. But we're going to do all of that. And then we're going to talk about how you can get involved. I'm going to show you what we're building at Strangeworks, and kind of how I'd like to see all of you, hopefully at the end of this, get engaged with quantum computing. So that said, it all started in 1927. So a lot of people talk about quantum computing, and they talk about it like it's this brand new thing that's a few years old, and it sounds really hokey, and it might not happen for 100 years. It's been almost 100 years. 1927, Schrodinger and Heisenberg and Einstein and all of the physicists got together at the Fifth Solvay Conference, and this is where quantum mechanics is generally said to have been born. This is super, super cool, but it doesn't mean they all agreed. Obviously, almost 10 years later, in 1935, Einstein wrote his paper about the Einstein-Polsky-Rosen paradox, kind of questioned whether things, what he called spooky action at a distance, whether entanglement could be faster than light. And of course, Schrodinger, this is also when he came up with this famous Schrodinger's cat experiment. It was a cat in the box with poisonous gas, alive or dead, and you don't know if you turn the gas on, it could still be alive. You gotta look and see. It's a thought experiment, though. A lot of people confuse it with a real experiment. I am pretty sure he did not murder a bunch of cats with poisonous gas, although things were crazy in 1935. I wouldn't have put it past him. But here's where we get really exciting. 1982, so 1980, a guy named Benioff writes a white paper called The Computer as a Physical System, and effectively argues that if you look down at a transistor, there's a physical electron that represents that information, and that all information is physical. And then 2 years later, he, along with Mann and Feynman, wrote a white paper and basically discussed using a Bloch sphere as a bit. This is the fundamental foundation of quantum computing, and one of the most important things in the history of it. Many years later, in 2000, Los Alamos had 7 qubits. Okay, not a lot. Get to 2006, the Institute for Quantum Computing and MIT have 12 qubits. This is clearly nothing to write home about, right? And then, of course, in 2017, which is about the year I was looking at starting Strangeworks, IBM achieved 17 qubits in a superconducting architecture and then achieved 50. And of course, the following year, Google achieved 72 qubits with their Sycamore processor. Think about that for a moment. And then think about the way I like to position this. I like to position it as 2023 is 1963. And it's one of the greatest times to be alive and write software in the history of all computing science, because it's the first step away from a von Neumann architecture, the first actual new form and architecture of computing since the dawn of computing. And it is super, super exciting to me, because in 1963, why do I say 2023 be like 1963? In 1963, you had the integrated circuit coming into the market. 1958-59, Jack Kilby invents it. Before that, you bought transistors one at a time. And that kind of started the march towards modern computing. Well, we're about to hit a big reset button on that. And it won't just be about quantum computing. It'll be quantum sensors. It'll be a quantum internet. It'll be quantum mechanics coming into every aspect of our lives, even consumer products. Quantum computers, why is Google invested so much in quantum computing? Because search is still their primary source of revenue. And because you can do things like use Grover's search algorithm, which would need only the square root of the number of entries in a database to get to the same answer as a classical computer. So if you look at the pace of quantum and we kind of sum up the history, 55 years between quantum mechanics as a concept and using it in computing, another 18 years before we have any usable qubits, another 6 years to effectively almost double those qubits, and then in 1 year, we go from 17 to 50 to 72. This is why I get on stage here this morning, in Miami this afternoon, everywhere I can, to evangelize this, like Chicken Little yelling about the sky falling, about how you all need to be paying attention and getting into quantum computing, because it is not happening at the pace of classical computing. So where are we today? Well, right now, we're approaching the limitations of a lot of compute. High-performance TPUs, we do FPGAs, you've got the Grok processor and the Cerebrum and all these different customized processors, Tesla's building their own, trying to get more performance, just squeeze it out of these current architectures that, to be frank, probably don't have that much more performance to give and do an amazing job at the things that they do. We don't need to make them faster. We need a completely new form of computing. And this is where quantum computing comes in. Because right now, if we wanted to travel to 14 cities together and we wanted to do the optimized path with all the variables we could account for, weather, lodging, travel, etc., I could write a script on this computer that would do that in a few thousand seconds, right? In almost any language. But if I go from 14 cities to 22, a difference of only 8, that same laptop would take somewhere between 4,000 and 6,000 years to get to the evaluation time of that problem. If I went to 28 cities, that laptop would take longer than the time of the known universe. This is what's called an intractable problem, and this is at the heart of where we're at computing-wise and where quantum computing can deliver us, which is the ability to do problems that it's not that a classical computer can't. That's one of the big myths in quantum computing. It's that we wouldn't want to wait around for the answer because it could take thousands or tens of thousands or millions or tens of millions or in some cases hundreds of millions of years for our current largest supercomputer to get to an answer that a quantum computer might do in minutes or days or weeks. We don't know yet, but it's going to be a lot faster than millions of years that we're going to be alive to get the answer, so that's pretty exciting. So how does it all work? Let's jump right into it. I always use this coin example, which either works really well or doesn't. I have a challenge coin. It has a heads and a tails. And if I think about the way your iPhones to the greatest supercomputer in the world work, if I take that coin and I put it heads up in the palm of my hand, it is a 1. If I flip it over, it is a 0. And in that two-dimensional plane, it can only be one of those binary outcomes, never anything. Now, classical computers are not going to be replaced by quantum computers. They work together, right? It's a new thing. That's a first myth I want to dispel. Second myth is a quantum computer, a qubit, can be 1 or 0 or anything in between. That is 100% false. Think about thinking that same coin. Instead of a bit that's in that binary state, let's make it a qubit. And let's flip the coin in the air. And when it's at the top of that spin, is it a 1 or is it a 0? And the answer is it's in a quantum superposition of some probabilistic outcome of a 1 or a 0. And just like a coin toss, until we toss it, catch it, and measure it, we don't know if it's collapsed into a 1 or a 0. So this is what I was saying in the opening. You can tell how a computer works. We can put verbose and watch everything it's doing. Can't do that with a quantum computer. Now, let's get into a few of the details on why. Well, classical computers, if I have 4 bits, I have 16 outcomes, and I can be in any one of those outcomes at the same moment in time. And if I add a bit, I go from 4 bits to 5 bits. I go from 16 outcomes to 25. Same rule, I can be in any one of those at the same time. Now, that magical qubit we talked about, if I have 4 qubits, I can be in all 16 outcomes at the same moment in time. And even more important, if I add a 5th qubit, I don't get 25 outcomes. I get 2 to the n the number of bits with every single qubit I add, meaning that these systems are jumping from 12, 15 qubits when I started the company 5 years ago to hundreds and thousands of qubits already. Think about the pace of that compared to the pace of the computing history we've known. So why do we need this power? Well, I like to think of it this way, and this also is how I like to think about that third, kind of rail of quantum's going to replace classical. You see people in quantum industry saying you're going to have a desktop quantum computer in 5 years. I will guarantee you will not. You see people saying it'll be built in your phone in 10 years. I can guarantee you it probably won't. Eventually, maybe. But how do we make these computers? Well, you take something like a salt atom, you blow it up real big, you pull an electron off, you trap it with lasers, or you freeze it almost to absolute 0, and then you can manipulate it. And so I'm just not seeing that in the iPhone 18. Call it weird, my Nostradamus-like capabilities. But why do we need this? Why is it so important? Well, think of this analogy. Think of, we used to cross, what I was thinking about it, and it's like, we got this camping theme going on. We used to cross from New York to San Francisco. And that journey took weeks, sometimes months. Sometimes we never completed it. Somebody might have died. You may have had to eat them. It was weird, okay? But I was thinking about that, and then we got the rail system. And that same trip took like 6 or 7 days. And it was safer, and it was faster, and that was awesome. So think of the wagon that we took on that first journey as an abacus and counting machines and things like that. And think of the train as the first computer. And that's about the effect that it had on us, as a society, right? And so you have this first computer, and eventually, now we can go all over this computational landscape. But no matter how far we go, eventually we reach an ocean of computational complexity. And what do we need? We need a new form of travel. So I like to think of quantum computing as planes versus classical computers as trains. Planes didn't replace trains anywhere in the world. There are societies in Japan and Europe and everywhere that are super train dependent as a form of public transport. And they work in conjunction. I fly to Japan, I take the train into the city, right? Think of classical quantum computers in that kind of relationship, and you'll be a lot further ahead than many people, even in the space that I work with. So, where can this be used? Everywhere. Machine learning, pharmaceutical materials. Think about new drug discoveries. Think about financial transactions, especially all the stuff we're doing with crypto. Security. Speaking of crypto, I hear that's really important in crypto right now. Like, they are 100% security focused. I apologize if anybody works in crypto. That is super insensitive. But you work in crypto, so. Anyway, data science, logistics, all of these things. And I'm going to show you real-world use cases that people have done here. But, this is the big question. When is it coming? When we started this company, I used to say, we make software for computers that don't exist. And it was hilarious. And then they started existing in lab benches around the world. Literally, they're on a lab bench, and you're like, hey, what's the API for that machine? They're like, is it this cable? And you're like, nope, it's not. But this started 5 years ago. I used to say 30 years for pessimist. I used to say 10, 15 years for optimist. And then my clever joke, but if you're a realist, you're preparing today. Because you can't take a developer and make them a quantum computing developer overnight. It's probably a 24 to 36-month journey at a minimum, okay? Right now, standing before you today, preparing to leave here after visiting with you guys a little bit after and head to Miami to give another talk on quantum computing, I will tell you that 7 years is probably 5, and that 3 years is less than 3. I don't think we can pick a number, but I believe this year in 2023, you will see some of the first inklings of the power that these computers have. Think about, we split the atom and we destroyed 2 cities. A horrific display of the power of atomic energy. And then we took and we said, let's make energy with that. And now we're going to make computers. And I'm telling you, it'll have as big, if not a bigger effect on the future of our species, which is why it's important. So what's the state of the industry? All right, so first of all, big question is quantum advantage. Do they do something that you can't do on a classical machine? The answer is yes. John Preskill published this paper now, December of 2021, where they proved using about 1,300 quantum gates, about 40 qubits, they could do machine learning experience that you just could not do on a classical computer. Now, does that mean it's ready for production? It does not. Does that mean that you should immediately quit your job and go into quantum? I mean, I think you should, but maybe not. Think about it. Here's the thing. It works. And, where's Clark? Where'd he go? What's your first computer? Okay, he has TRS-80, right? So how many of you had a TRS-80 or something similar? Commodore 64? What? Okay. That thing's a piece of crap compared to your iPhone, right? Or your Android phone? So why'd you use it? Right? Because everybody wants to know, why should I be trying to use a quantum computer today? It's like, because it's the next thing, you need to learn it, and it's going to be really huge. I can name 100 reasons. But because you always adopted new technology early, right? Haven't you always taken the new technology and used it to the best of its extent? I mean, the first computers could barely do a spreadsheet. There weren't spreadsheets, So I really encourage you to look at this. This paper is a great example of something that is done. There are so many more. But here's the other reason I think you should get involved. When we started, there were very few programs. Yeah, there it is. Maybe quantum startups, 15 worldwide 5 years ago. There's 230 that have more than 3 to 5 people and more than 3 to 5 million in funding. There were 2, maybe 4, depending on how you count them, quantum information degrees that were master's degrees. There's now over 40. There were 3 technologies, annealers, where you're cooling things down, superconducting circuits, you're cooling things down, and ion traps. And the ion traps were, trapping them with lasers. Now there's 9 different technologies. Making a qubit is not hard. Making a qubit without the fidelity of the system going to crap is really hard. So there's going to be a market of 12 or 15 or 20 or 30 companies selling these machines, and they're going to work from a fundamental physics perspective in a dozen ways. And that all happens easily before the end of the decade, possibly in the next 36 months, okay? There were no publicly traded companies. There's now 5 publicly traded companies globally in quantum computing. Now, I don't believe the market can support that. A lot of them did that through SPACs, and I think that leads to a fate worse than death. But it is something to say that retail investors would support a technology like this that they can't possibly know much about. Because I've been working with it for 5 years, and I don't know jack. So I don't know what the guy on E-Trade knows. But here's what that's led to. When we entered this market, $20 billion worldwide invested in quantum computing. In the 5 years we've been in it, an additional $10 billion has been invested, which is astounding. So, public markets are talking about it. You've got these companies. CNBC did this special in November. They've done a couple since. YouTube now blocks you from taking the screenshots. So I got the old one, not the new one. But it's really interesting to see. One of the things you'll see on here is in that lower left there, 80% of the investment has been in hardware up to this point, which I find phenomenal, like ridiculous. And then even these two can agree. So it doesn't matter what your politics are. Both administrations, every government around the world, Sweden, the Netherlands, France, Germany, Japan, China, the US, Korea, on and on and on, are investing billions of dollars in quantum computing for national security. And we'll get to why in a minute. And funding, 2021, there was $3.2 billion, $1 billion of it in the last year. 2022, there was almost $1 billion in just the first quarter, and there was one startup seed round in quantum computing that was over $1 billion invested. Think about that. That's insane. So let's get into why all that money, why all this stuff. Let's talk about some science here. So Shor's algorithm, how many people have heard of that? We're going to break an RSA encryption key. How many people think quantum will break encryption in the next 10 years? Keep your hands up. 5 years? Keep your hands up. 3 years? 2 years? Wow, some visionaries over here, but I think they're right. If we're going to break it, Shor's algorithm, made in 1994 by Peter Shor, is the algorithm that everybody thinks to be used. Now, you might have recently read China did a report, which is where I think the actual value in quantum is going to be, where they did not use a quantum computer to break a key, but they did use a classical computer and then used a quantum computer, optimize what it was doing, and to do a couple little offsets and claim that they were able to break an encryption key. All right. First of all, it's 100% going to happen. It's definitely going to happen before the end of the decade. It could happen in the next couple of years, and you shouldn't be that worried about it, because there used to be this machine called the Enigma machine, but nobody uses that anymore because that's how security works. And building it where it's time and resource for us to protect our valuables is stupid to begin with. So yes, a quantum computer will cut through that. The thing you need to think about is that's not the scary thing. The scary thing is 30 years ago, some spy from a country that doesn't like America stole the secrets on how to build an atom bomb, and a quantum computer will be used to cut through that over the internet probably in the next 2 or 3 years for sure. All right, so the encryption thing is, that's really uplifting, right? Everybody's super stoked now. This is important to know, though. This is the kind of world-changing stuff it's going to do. It's going to change the balance of geopolitical power. You don't see a quantum computing press release from China every week for nothing, right? Some of it's got merit, some of it's fake, but they want everybody to know that's the new thing, and they're going to lead it, even more so than AI. So this is Shor's algorithm. This is how we break it. It basically has 5 steps. And so we're going to run through this one and another one real quick. Let's say step number 1. Let's pick an odd number. We're going to pick 15, okay? Step number 2, is it a factor of 2 coprimes? Because that'd be awesome, and it is, so we're good. And then we say, let's pick a random number to use in our calculation. I'm going to pick 7 because it's got to be a number that's not a factor of 15. 7's not a factor of 15, okay? And then we get to step 4. Find the order R of X mod n. This is the non-deterministic quantum magic. This is where all of the cool magic happens. This would take a classical computer millions and millions of years, would take a quantum computer a few seconds. This cannot be duplicated on any classical machine of any architecture, even if you dreamed up NVIDIA supercomputer 10 years from now, still just is incapable because of architecture of doing this kind of math. And then the last one is, hey, did that work? If it did, we took your public key and I derived your private key, and if it didn't, we go back to the beginning and we start again. Here's an interesting thing, and this is why classical computers will still be around. I could write an iPhone app to do steps 1, 2, 3, and 5 so blindingly fast, it would be a waste of money and resource to use a quantum computer to figure out if it's an even number, right? So you're always going to have this pairing, and that's a great example, I think, with Shor's algorithm of where you see a quantum computer come into being. So, let's slow down. 15 is 3 minus 5. When we started, this was the biggest number that had been factored. There are now, again, claims of factoring and keys and other things. It's going to be a very, very interesting place in the world. So that's one example. The other example, the real power of a quantum algorithm is in that search thing we talked about. And so how many of you guys know the drunken walk? Anybody? Thank God. This is the only audience anybody has known the drunken walk. So classical computer, we're at an Austin FC game. We're going to find my buddy. I'm going to go up and tap somebody on the shoulder. You know what? And I've got that magical coin again. And so if I take that magical coin and I say, hey, it's not my buddy, I'm going to flip it. Heads, I'm going to step over to the right, tap the next person. Tails, I'm going to step over to the left. When I do that, I basically, looking like a standard search, all the probability densities in the middle here, looks like a bell curve, not very exciting. But what if that was a quantum coin? And what if I walked up, I tapped my friend on the shoulder, I flipped the coin, and I could go in both directions at the same time, right? That's the power of quantum computing. And what that means is that my probability density changes. And now it looks more like what we like to jokingly call vampire fangs, as opposed to that, which means I am searching a wider swath of more information, and I can, in a very, very few steps, explore vast amounts of information incapable of a classical computer duplicating that. So, what have people been doing with it? We're going to rocket through these, and then we're going to get to some resources where you guys can start programming. Volkswagen, they're using it for autonomous vehicles. They're using it for the routing. If you have an autonomous vehicle future, that's it. You want an electric vehicle future? We're going to need quantum optimization to figure out that power grid, because if everybody had electric cars and you all plugged them in, nothing would work. So lots of stuff with optimization of paths, optimization of electricity, where stations are, how the grid is managed, et cetera, et cetera. Mitsubishi, and this is my favorite example, took the trash truck routes in Japan from 2,300 kilometers to 1,000 kilometers, which is a great savings, obviously, on wear and tear on the vehicles and other stuff. Toyota and Denso are doing multimodal transportation, similar to what Volkswagen's doing, but they imagine drone ships bringing your new Toyota car to the States where a drone crane unloads it, et cetera, and they're using quantum computer to figure out all of the optimized paths and placements of these things around the world. Deutsche Bahn, 40,000 trains traveling 5,700 stations every day. They optimize all the routes. Similar, Exxon did this with where their tankers are going. Really cool, Frankfurt Airport has 278 gates, 170,000 people traversing them every day. And they put together a quantum optimization on how to move the gates, where to land planes, and schedule things to make those transit times more efficient for people, to make that airport more efficient. And Airbus, of course, is exploring everything. And these aren't the only ones. Ford has looked at it. I mean, you at this point can't name a company that hasn't done something or has one or two people that have done something in that. So what's the future look like? Well, this is where we're going to get into it in the last few minutes we have here. we want to bring quantum to the people. So we built software. This isn't a pitch. You can use it for free. Always have been able to, always will be able to. Some of it's open source, some of it's not. Unfortunately, that's because of all the quantum licensing stuff we have to deal with. But we believe that software has one job, and that one job is to eliminate complexity. And quantum computing is super, super complex. And so we thought, what if we could build a tool for developers to basically take that complexity of quantum and eliminate it? And we thought, well, if you were going to do that and you're a software developer, you'd make everything software. So there are, in that corner, let me see, 3, 6, 7, 8, 9. There's now 12 open source tools and utilities listed. These are all of the frameworks that you need to start developing in quantum. So Qiskit is from IBM, free framework. It's probably the most popular. I don't say that because IBM is one of our partners. We're partners with everybody. But it's undeniably the most popular. Google has Circ, which is also pretty popular. Very, very good framework for you guys to consider looking at. Microsoft has C#, okay? And C# is, interesting. They've got a bunch of katas that you can learn, but that's going to put you in a very Microsoft-focused area. I like sending people to Qiskit because I do believe, one, it's open source. Two, I believe it will be carried through to other providers, and as it's carried through to other providers, I think if you know it, you'll be able to use multiple machines, and already some others use it. Rigetti can take Qiskit stuff. Honeywell can take Qiskit stuff. But quantumcomputing.com, which is where we started, was a little bit of a distraction, will go away at South by Southwest. And when it does, it'll be replaced with just the portal at Strangeworks. And if you want access to that, and I'll show it to you in just a second, I'm going to show you the platform, you can apply for what we call Backstage Pass. And I would love to give every single one of you access to these machines and to this software. Because the reason quantum computing hasn't went further faster is a lack of developers. I said that 5 years ago. I say it again today. We are some of the only software people in quantum. I can literally count the actual software talent in quantum on my fingers and toes, for sure, mine and my 5-year-olds, right? Like, there's not a lot. There's maybe 200 or 300 people in quantum that matter worldwide right now. So important to keep that in mind. So we thought everything should be software so that everything can be basically definable and deployable and dependable. So if you think of like Kubernetes for quantum, it's kind of what we've built. So you can go in, you can use any one of the frameworks turnkey, the ones I mentioned, Qiskit, Circ, or Q#. You can also use things that are quantum inspired, like QQuantas from NVIDIA and others. They're already built in. You don't have to update them. You don't have to do anything. And then you just deploy resources. So in this case, this box on the left, it says add a resource, deploy resource. That's just an IBM machine. So as a software developer, I don't need to worry about the quantum physics or any of the complexity of that stuff. And so you can basically select and manage all of your stuff. We've got this huge, like I said, it's almost 50 partners now. And then I'm going to show you a couple ways that people are integrating. So where do you program? Well, quantum computing had an IDE. We got rid of that. You program from anything you want. You want to use Jupyter Notebooks, which is not how I think any software developers write software, but you feel free. And you'd be a happy little physicist. Or you could use any one of a number of actual tools that software developers use and do the same thing. It's a simple SDK call. And let's take a quick tour of that and show you guys where to go and how to get signed up. All right, so this is the portal when you come in. Like I said, you can just generate your Strangeworks API key right there. This is gonna shock every developer in here, but there's actual real documentation. I'm pretty sure it's free of spelling errors and actually helps you get started with the software. So astounding innovation we've discovered at Strangeworks. So quick tour. So this is it. You know, everybody says, well, how can I get a quantum computer? What do I have? Just to give you an idea, I don't have all of them. I have 91 quantum computers online right now that you could use. Okay, now the cost could go from $0 to $2,600 an hour to $125,000 for, whoops, what was that experiment we ran? But we can help you with that too and get you to free resources. QEra's new Aquila machine is on there, all the Rigettis, anything you have in bracket, the IonQs, everything can be managed. But here's the important part and the kind of call to action for you. We also have this beautiful product catalog. All of those open source tools are covered. As I said, you can go in, if I pick an IBM computer, and all I'd have to do is just deploy it as a resource. I don't need to think about it. I just say, let me add one. I can go in and see what projects I've got them in. Think of a project, it's just a workspace, right? You just go in and customize whatever you want. But the important part and the opportunity for you is, we have this idea, if quantum is so complex, why don't we start encapsulating the complexity just like we did in the hardware on the software side and build these little managed applications, okay? And so we started by building things like a variational quantum Eigen solver, which you guys are all going to be astounded to find out finds the minimum eigenvalue of a Hamiltonian, which means nothing to any of us. But I'm kidding. It now unfortunately means something to me. My wife is like, you're doing that thing again. I'm like, what? But we built services like this QAOA. This is a quantum optimization service, but this service is pre-packaged to run on AWS, hybrid jobs, can run in IBM's infrastructure, et cetera, et cetera. The reason I say I want to point this out as an opportunity is because I am going to every developer event I can, recruiting developers into quantum. Until more of you join quantum computing, call the hardware vendors out on any bullshit they have, give them feedback on what we actually need, this industry is not going to move forward. I've said that for 5 years. There's a couple dozen software engineers in it now. It's already made a huge difference. We need hundreds. We need thousands of software engineers that are going, yep, this is the thing. I'm doing quantum. This is the direction that I'm headed in. And so we would like to invite you to apply on the Backstage Pass, which I'll show you in a moment, to come and not just play around with it, but if you want, to build services and apps. And I will switch back over for 1 second and show you some examples of how people are doing it. So as a developer, if you want to write an application, you no longer have to write it and do it. You can actually write it on the Strangeworks platform, host it there, and make it available in a marketplace to people. Rigetti, who's one of the hardware vendors, recently said, we're going to divest of software. They moved their quantum kernel alignment and their convolutional neural networks onto the platform. Pardon me. Integration examples. If you have a product or you're at a company that wants to integrate with quantum computing, we now offer a way for you to do that. Very free or cheap and easy, depending on what your use is, whether it's commercial or university or whatever. But you can actually take your applications. BosanQ is a company in India that does very advanced simulation software, decided why would we mess with any of the quantum? We can just call the Strangeworks platform and access all the machines. So you can write apps, you can do that. Deloitte is a really, really good example of why to write them. So Deloitte has this thing called a smart factory that's not photoshopped. It's a real factory. And it builds those little cars you see on the right there. And so it's shown to prove, how automation works. You can embed the app. So what they were doing was extracting training data, doing a little kernel calculation, updating the parameters, and then sending it to us. We would build that circuit, and we would send it to one of these machines, either the QVM, the 80-qubit, or the 40-qubit. So they did hundreds of experiments. They ran 130,000 jobs. But what they found out is now with the new version we're releasing at South by, you can actually write all of that software straight onto the platform. And when you do, you see about a 10x speed up on top of about a 48x speed up that we had already seen. So, I would like to call for all of you to get involved with quantum. We've taken a lot of the complexity out of it. We've made it free, very easy to use. If you have a really cool experiment you want to do and you really need machine time, we've made it easy to get that through us. So we've bought machine time. We've had people that have donated it from hardware providers and other orgs. So if you have a really cool project and you're like, look, this is a great project, I could write this software, I just can't get access to a machine to test it, I'll give you a machine. So there's literally nothing stopping you from getting involved. And like I said, you are living in the greatest time to be an experienced software developer in the history of all of computing. Never before has there been a moment in where you're going to be on the forefront of a completely new technology that is going to change every single aspect of our lives. And let me tell you why I'm in it. I don't care about better drug discovery. I give a lot of shits about curing disease and just eradicating it. I don't care about better battery technology for my electric car. I care about completely new modes of transportation we've never dreamed of, right? I'm not worried about it breaking encryption. I'm thinking about, wow, what happens when we have a quantum internet? And the simple act of trying to observe a communication between Clark and I means you disrupt the whole thing and it decoheres, so you can't get any secrets. Sounds incredible, right? These are the things that inspire me. This is why I got into it. This is why I continue to stick with it. And with that, I will take 5 minutes. I believe I have. Where's Clark? I do. I do. Okay, all right. Did you want me to in ride or do you want me to go a few minutes? I was going to. Okay. So I got about 5 minutes. I thought it'd be probably more useful if you guys have any questions and anybody wants to ask any question about anything, quantum industry, programming, gates, development, doesn't matter. And I would be happy to answer those as succinctly as possible. I only left 5 minutes because I was worried there wouldn't be any questions. But fortunately, I got a ringer in the audience. Wesley, yes, sir. my good friend who I can always depend on.
Are any companies in quantum hiring for developer relations?
They are. I would say of the 20 or 30 that I would say like in the top, I would say almost all of them. StrangeWorks is not yet, although you would be top on my list. Developer relations, I think, is something that, we need to grow the developer community in quantum, okay? And we need to grow it outside of just the physicists at the universities, and we need to grow it into our community. And so I'd say they're all already hiring for that type of stuff. However, that's going to get super amped up the moment we pass, call it 10,000 developers noodling on quantum on the weekends, right? Because we don't have anything near that. But yeah, there's a lot of jobs. And by the way, quick comment, you don't have to have a degree in quantum physics to get a job in quantum either. Like the industry is now starting to take off. They need people in marketing and regular software developers and people that understand classical hardware and all manner of jobs. Any other questions? Yes, sir. So that's a great question. AI and quantum computing, are they not solving for the same outcome? So think of it, I like to think of it this way. Think of it as your classical hardware, software kind of battle. Think of the quantum as hardware and the AI as the software. So hardware guys will tell you how the software won't do anything without the hardware guys. And when I was at Apple and R&D, that used to all the time, the hardware guys were like, well, if we didn't build this hardware, you'd have nothing to work on. It's like, right, but if we didn't make this like go click, like nobody could use it. Think of it like that. Think of it like quantum. There will be quantum software, and there is quantum machine learning and quantum AI projects already be working on. But think of it more like a hardware-software difference. So think of it as quantum as being this new type of hardware and capability, and think of now taking AI and applying to that and just kind of supercharging, most likely the path to a superintelligence. All right, I think I got time for one more. Yes, sir. We'll try to go real quick to both of you. I was pointing at you. It's okay.
All right. What would you see as the first demo where developers are just like, yes, I have to get into this, and I'm going to start learning this. Is it coming? Is it here? What do you see being that first demo that absolutely changes people's minds?
Wow, that's a great one. That's a really great one. The demo that will convince people's minds. Well, if we go in, sir, are you not convinced?
Oh my goodness!
Please. If I have to sell this to you down here in the, because this is the output you get. It's beautiful. Come on. Look at that. It's 42 items all the way down the line. It is a little bit of a problem. The question, all jokes aside, being, what's going to be that app? I believe that the moment ChatGTP runs on Quantum, millions of Quantum developers. I'm just kidding. I think, I can't believe only 2 of you thought that was funny. Because I thought that's how you solved all development problems, right? Isn't that what every developer is telling their manager? Don't worry, we're integrating ChatGTP. And the manager's like, oh my God, it's magic. And you're like, it sure is, boss. Getting developers excited is going to be hard. Here's the problem. There's a paradox. The app that will probably do it is probably going to be like, encryption just broke. And for sure, every developer said, right? Come down from that, it'll probably be like, oh, we did this amazing optimization on machine learning, right? Come down from that. So there's multiple different apps that would probably be like a boon to the developer community. The problem is it's really hard. You have to understand superposition and entanglement and teleportation and stuff. And if you don't, it's not a problem. It's just like if you're in the Microsoft tools and you instantiate teleportation and then it breaks, you're like, teleportation doesn't work. So, click, right? I mean, what do you do? So much like in the early days where you had to be an electrical engineer to understand the flow of electricity between the gates, you kind of have to be a physicist to understand some of the basics of the machine. We're trying to push us away from that as fast as possible, adding those abstraction layers and stuff. But, that's probably the toughest question. And by the way, I know the reality. I show up, I talk about quantum. You shake your head. You shake your head. Some people over here are shaking their head another way. And none of you will do this, but I want you to remember this moment. I challenge you to remember this moment in time when you're like, oh my God, I got to learn quantum computing tomorrow. I'm years behind. Call me up so I can just be like, I told you so. Because I've been doing this for 30 years, and I've never, and Wesley and several people here know me, I've never put my personal reputation on any technology. I've just been I use the technologies, right? I'm not a part of them. I don't want to be part of the movement, whatever. From Apache to Nagios on to BMC and Tivoli, from Apple to IBM, that's been my thing for my whole career, like a technology mercenary, okay? This year, granted I can get off my butt, I will launch a new whurley.com. It'll be all about quantum. It's like, I am your quantum guy. And that's how much I believe in it. I believe that I don't need a job, that I don't need to be doing startup hours at my age. I got a soon-to-be 7-year-old and a 5-year-old that I'd like to spend a lot more time with, and a 26-year-old starting his own startup. But I tried to start this company as an open source project with the Linux Foundation in 2017, and I couldn't get any of the quantum companies at the time to work together. Now that has changed dramatically, but nobody wanted to work together. They're all going to own a vertical stack worth trillions of dollars, and you were all going to work for them as well. Is a brilliant plan that they laid out. But that was a problem for me. And so I said, well, I got to go start a company to do it since I can't get an open source project going. And so now the irony is the company will spin off open source projects with Apache. We're working on proposals already with Linux Foundation. And I hope you all take advantage and participate in those too. But look, it's not easy. I don't want to fool you. It's hard. It's really hard. And the physics is hard. And it's a lot of linear algebra. So boring. And it's not something that you can just dip your toe in. Now, we wrote a book called Quantum Computing for Babies. It's available on Amazon. We used to give them away, but we're phasing it out because even though it's the best-selling book in quantum, in September, we'll announce a new book, and I'll kind of let everybody here know and online early, which is we're writing Quantum Computing for Dummies with whurley. And so that is the follow-on to Babies, and then we'll have another one after that and another one after that. Check out the Babies book. Google Linux Foundation quantum computing training. We worked with World Bank and Linux Foundation to do a free training on basics of physics and what's teleportation and entanglement and superposition and how they work. go use these free resources. We started quantumcomputing.stackexchange.net. Go there, ask questions. If you need help, I'm whurley on Twitter, on LinkedIn, on everywhere. Shoot me a message. It may be a week or two before you hear back, but you'll hear back, and I'll point you in the right direction to a resource. Watch for the StrangeWorks announcement at South by. Do get involved early. If you want to get involved early, you simply go to our website, and right here under the fold is, oops, sorry, that's not up there, is an apply today, and you can apply for a backstage pass, and the one you want to do is a StrangeWorks beta program right here. And we can get you access to all of those quantum computers and the software early today, and we'd love to do it. All we want is your feedback. Tell us what doesn't work. Tell us what's confusing. Tell us what you need to become the greatest quantum software developer on the face of the planet, and we will build our part of it for you. Thank you very much for your time. Appreciate it.
You know that moment we were talking about earlier where I talked about everything being kind of this small world and connected to one another and whatnot? And then here the quantum guy gets up and, I don't know, I'm sitting over there going, shit, I messed up. I should have been learning math a long time ago. I've never felt like I've had bigger imposter syndrome after listening. It's moments like these where you can, and Whurley said it, you're going to have that moment where you're like, I should have done that thing. And the fact that you're here and you stepped out and invested in yourself, like, that's why I do this. And I think it's super cool when you can just get your mind bent around something that, me personally, hell, I don't even know where to go with it at the moment. I need like a glass of bourbon and apparently the book for babies. I want to thank Whurley for taking the time out to be here. He has an extremely busy schedule. As you heard, he's jumping on a plane to go to Miami. Let's give him another round of applause. I'll make sure I send out the links to things, whatnot, so that everybody has it. I know I'm going to sign up and sit there and go, I don't know what I'm doing. Much like when I look at some of my JavaScript code. Again, Open Spaces will kick off at lunch. This was recorded. It's online. We'll do some editing and stuff with that too. We actually are starting a podcast, so a whole bunch of people in here. We're kind of running through things and having some fun with that. Again, I want to go through some of the sponsors and just thank them. Make sure that you go and stop by, see them, talk to them, understand what they're doing. Not everybody actually has a booth. Some are just here having fun. Intellibus, right outside, stop by and say hi to them. Vonage, had a bunch of fun with them last night. Some friends that kind of go way back. Front Egg, new this year. Yum, Eric's around here somewhere. Passage, Leading Edge, Robert Half, Auth0, the Alexa team, Progress, AWS, like even, Virtual Coffee, Code and Coffee, Compressed FM, where's Quick and Amy Dutton. The ATC, all of us have to play together. We can't do this without any of them. We're always looking for sponsors and partners that want to help continue to do what we're doing for the next 3 days. So let's give them a big round of applause. I'll leave this up if you want to get connected to us in Telegram, just so that you can get notified when things are coming up. One for Wisconsin, one for Texas, and then just kind of one overall. With that, thank you for being here. Thank you for being part of V2. More importantly, thank you for setting the culture of whatever that conference Texas will become. This is not my conference. I am simply the person who puts these fake trees on stage and ships them across the United States. I'm simply the person that sends out some email. It is you that make the community, not me. It is you that give back to one another. It is you that set the tone. It is you that set the behavior. It is you that make this what it is, not me. I'm part of it. I'm humbled to be part of it. Love every one of you. Thank you for being here. Lean into the next 3 days, and let's have some fun. Thank you very much.